I want to address the question on why this is true. Why is it that for a 30, 60, 90 triangle we can multiply the small side by 2 and get the value of the hypotenuse? And likewise, why is it that we can multiply the small side by the square root of 3 and get the value of the medium side, which is always across the 60 degrees? So these kinds of questions were usually the types of questions that always gravitated me towards math. And I know that many of you may not share my point of view on mathematics, but I feel that it's still my duty to at least address this situation. So let's go ahead and get started. And the idea behind the 30, 60, 90 theorem stems from observing an equilateral triangle. Now, triangles, recall that all of the angles have to add up to 180 degrees. So if we have an equilateral triangle, that means that those 180 degrees have to be split up evenly into 3 pieces, making each angle 60 degrees. On top of that, in an equilateral triangle, all of the lengths have to be congruent. So here, I'm using a general length S. So all of my lengths are labeled as S. What I'm going to do next is I'm going to bisect this triangle. I'm going to cut it in half. So I'm going to grab a perpendicular bisector and I'm going to cut this triangle in half. When I cut this triangle in half, I bisected the angle, the 60-degree angle, and now I created two 30-degree angles because again I cut it in half. And being a perpendicular bisector, I also created two right angles, one right here, one right here. So now I have two right triangles inside of this equilateral triangle. I'm going to go ahead and extract one of these triangles. So once I extract this one, let's just call it 1. So this is triangle 1. You can see that I took with me that 30 degrees, that 90 degrees, and this 60 degrees. This length was S, so here we have S, but notice I cut this triangle in half. So then this length should be S over 2. This length should be S over 2. So here I'm going to write S over 2 for my length. S over 2. And we can immediately see now why the length that's across 30 degrees is always half of the hypotenuse. All that's needed is to figure out this missing length. And we can do that with ease because we have a right triangle and we have two sides. If we have two sides, using the Pythagorean theorem, we can find the third. So let me label this side and I'm going to call it M for now. So I have to solve for M. And Pythagorean theorem says that when you have a squared plus b squared, you're gonna get c squared. If you add these two legs, the square of these two legs. So let's go ahead and apply the substitutions. And here, c squared, that's gonna be my s because s is across the 90-degree angle. So here we have s squared on the right hand side, and we have m squared plus s divided by 2 squared. And let's go ahead and solve this equation. Again, we're trying to isolate m. So I'm going to simplify this. So we get m squared plus s to the second power. That's going to be s squared. And then 2 to the second power, that's going to be 4. So here we're going to get s squared over 4 equals s squared. I want to isolate m, so I got to get rid of this s squared divided by 4. So I'm going to subtract by s squared over 4, and I'm going to do that to the right as well, minus s squared over 4. On the left hand side, these are going to cancel. Nothing happens to m squared, so I get m squared plus 0, and that's going to be equal to s squared minus s squared over 4. So here I have s squared minus s squared over 4. I have common terms, but I don't have common denominators, so I'm going to transform this s squared into a fraction by dividing it by 1 and getting a common denominator of 4. I'm going to multiply the denominator by 4 and the numerator by 4. So here I'm going to get m squared plus 0 is m squared, and that's going to equal 4s squared over 4 minus s squared over 4. So we get m squared is equal to, well, 4s squared minus 1s squared is going to give us 3s squared. And since we have the common denominator, we keep that 4 here. And now to get rid of the square, I'm going to square root on both sides of the equation. So square root here, and here, let me do this better. We're square rooting everything. So here the square and the square root cancel. So I'm going to get m equal to, and here I'm going to distribute the square root to the numerator and the denominator. So I get square root of 3s squared all over the square root of 4. And I'm going to go ahead and simplify this even further. So I get m is equal to, well, the square root of 3. 3 doesn't have a perfect square, but s squared does. The square root of s squared is just going to be s. So square root of 3 times s all over the square root of 4, which is 2. So m equals the square root of 3 times s over 2. And let's go ahead and put that substitution right here in our triangle. So here we can erase m, and we can say this is equal to the square root of 3 over 2 times, or actually here, let me do it like this, to the square root of 3 times s over 2. And now you can see the ratios, why the ratios work. The side that's across 30 degrees, that's always going to be half of the hypotenuse. And to get from the small side to the middle side, and the middle side being across 60 degrees, all you have to do to this is multiply it by root 3. Now this is very, very abstract, but I wanted to at least show you the truth behind this and not just want you to take my word for it. So hopefully you at least got a kick out of it. But yeah, I'll definitely never put this on the test, but at least know how to apply the ratios. Okay, I'll see you on the next lesson.